Hi guys, so I just wanted to point something out to you that the slant asymptote is found by doing long division, and everything except for the remainder is your slant asymptote. So you should get a line when the degree is one bigger than when the numerator is one larger than the denominator in degree. You should get a line, and so that is your slant asymptote. Just forget the remainder that appears, if there is one. And so let's look at horizontal asymptotes. We have 4x over 2x squared plus 1. Degree of the numerator is 1. Degree of the denominator is 2. Therefore, y is equal to 0 is your asymptote, which means the x-axis is your asymptote. Okay. If we do part B, we have 4x squared over 2x squared plus 1. If we try this one to find the asymptote for the horizontal, then we notice the degree of the numerator is equal to the degree of the denominator. So your asymptote is that y is equal to 4 over 2, the lead coefficients ratio, which is y is equal to 2. So you draw your graph, and at 1, 2, you will have a asymptote, a horizontal one where it approaches infinity. And then finally, for the last one, we have 4x cubed over 2x squared plus 1. The degree of the numerator is exactly 1 bigger than the degree of the denominator, and since we're only looking at horizontal asymptotes, there is no horizontal asymptote in this case. Okay, so we are done with that. And then we're going to move on to slants. So we'll look at a neat example where we'll actually have one. And I can show you the process of finding the slant asymptote. Okay, so we just said if the degree is 1 higher, so I'm assuming this one's going to be 1 higher. Come on. Okay, so we have x squared minus 4x minus 5 over x minus 3. So we're going to divide that. We have x minus 3 here. X squared minus 4x minus 5. X goes into x squared x times. So if we multiply that back, x squared negative 3x. And then we change the signs, negative, positive. So this is x. And then we bring down the minus 5. Now we have x goes into x 1 time, so plus 1. So we put x, and then we do negative 1 and 3. That's negative 3. Change the signs. This is 2 negative. And then that's negative 2 over x minus 3. Now, our slant asymptote is going to be x plus 1. So how this asymptote would look, you'd graph the line x plus 1. So you go up 1. That is the, remember, this is y equals x plus 1. So that would be the y int. That's here. And then you go up 1 over 1 because the slope is 1 over 1. So up 1 over 1, you put your points. And then you just kind of graph the horizontal asymptote. And so you'll probably get something that looks something like this. I mean, I don't know exactly what it looks like, but you'll have something that does something like that maybe. That's not for sure because I obviously haven't checked any points, but that's kind of the idea. It'll approach that line, but it will never touch that line as it goes towards infinity. Okay, so graphing the functions, the y-intercept is very important, the x-intercepts are important, slopes and asymptotes and holes are important, and so we want to pick test points at some point. So let's do a couple of these and we'll see what we can pull from all of this. So first one we're going to do, we have 3x minus 3 over x minus 2. I'm going to factor this. This is 3x minus 1 over x minus 2. Okay, now let's figure out a couple things. Let's figure out the domain. Well, I can see right away that x minus 2 is equal to 0 gives me x is not equal to 2 because if it's 2, this bottom part is 0. Okay, so there's an asymptote. This is a vertical asymptote at x is equal to 2. As far as horizontal, this is 3 over 1. Y is equal to 3 over 1 because this is degree 1, this is degree 1, so this is y equals 3. There's an asymptote. This is equal to 0, so the y is equal to 0 when x is equal to 1. So let's look at that real quick. So we have 0 is equal to 3x minus 1 over x minus 2. We can multiply this to this side, x minus 2. Gone, gone. And then we divide the 3 out, and you just set x minus 1 equal to 0, and you get x is equal to 1 is your intercept. Y in, x in. Okay, so let's go and plot these couple of things that we know so far. So we know we have our graph. We know at x equals 2 there's a vertical asymptote and not a hole, so we draw a vertical asymptote. Then we have y equals 3, so 1, 2, 3. Okay, there's that, and then x equals 1 is our intercept. Okay, so x equals 1 is right here. Okay, so that's very helpful actually. So we know it's going to approach this line. Well, it can't cross that line, so this point must go something like this. And this one must come down like this. And then from experience, these are usually never next to each other. So I would assume this is up here. And that's just usually what happens. So you won't have it so that this comes up from here and goes this way. Just to check, let's do let's plug something in. Let's try 5. 3 times 5 minus 3 over 5 minus 2. This is going to be 15 minus 3, which is 12 over 3, which is equal to 4. So at 0.54 there's a point. So if we go over 5, 1, 2, 3, 4, 5, we go up 1, 2, 3, 4. Oops, I didn't go up high enough. Sorry, that's not the right point. You can see that it's actually above that asymptote because this is y equals 3 and that y is 4. And so you can see that I have actually graphed the right one, and I can check. You can check it with Desmos. I'm not going to because I'm pretty sure this is good. All right, so let's look at 2x squared now. We have 2x squared over x squared minus 9. This is 2x squared over x plus 3, x minus 3. So you know we can get the vertical asymptotes really quick. Guess what they are? They are x equals 3 and x equals negative 3. Okay. How about vertical asymptote or horizontal asymptotes? X squared, so they're the same. So then it's going to be is equal to y is equal to 2. How about our y equals to 0 point? That's when the numerator is equal to 0. So 2x squared is equal to 0 at x is equal to 0. So 0, 0 is a point. That's our intercept. And then I think we're good on everything. So let's put all this together. We have x equals 3. 1, 2, 3. We draw a vertical asymptote. 1, 2, 3. We draw another vertical asymptote. Y equals 2. That would be up here. 1, 2. We draw a horizontal asymptote. Okay, now one thing to point out, we have 2x squared is equal to 0, so that means we divide by 2, x squared is equal to 0, so square root of x squared is equal to 0. Remember, so 0, 0 is a point on this graph. Now, one thing to point out to you, this point, it does not pass through it, because if it passed through it, there would have to be another 0 somewhere on this side or this side. So it must be the case that this thing goes like this. How do I know? Because if it was upward facing, it would have nowhere to go because it would get trapped right here by this corner. If you don't believe that, if that doesn't help, let's try plugging a -2 into this and see if it's a negative or positive value. So let's do 2 times -2 squared over, we have -2, minus 3, no, plus 3, -2 minus 3. And we're just going to check if it's positive or negative. So this is going to be positive on top. So this is 2 times 4. And then this is going to be 3 minus 2 is 1. -2 and -2 is -5. And so positive, positive. So this is positive over negative is, yep, it's negative. So we know that it's somewhere down here. And that's all we have to worry about. So we've got that graphed perfectly. Now, as far as experience tells me, they're not going to be on the same side where they approach the same infinity here. It will actually look something like this. And we can obviously try -5 or 5. Let's just try 5 for this case. So we have 2 times 5 squared over 5 plus 3. 5 minus 3, which is going to be 50 over 5 plus 3 is 8, and 5 and -3 is 2, so 8 and 16. So this is equal to about 3 point something, because 16 goes into 48. So we see our asymptotes at y is equal to 2. This point is at 3 point something, so it must be somewhere up here. And therefore, I know this is a good graph. So the rule I'm kind of using is it won't approach the same infinity on this side of this as this will. Okay, that's basically what the rule I'm using is. We can do x to the 4th, x squared plus 1. Okay, let's get our asymptotes. We have x to the 4th equals 0. We've got y is equal to 0. So we've got 0, 0 as a point. It will not cross through 0, 0, just like this graph did not. It kind of bounced off of 0 and came back down. If you don't believe it, obviously try 2 and you'll see it does it again. So that's taken care of. Horizontal asymptote? None. This is degree 4, this is degree 2. The numerator is higher than the denominator. Slant asymptote? None, because this is 2 bigger, not 1. And vertical asymptote? Your answer is none. Why? Because this is never equal to 0. This is the graph that looks something like this, and so you can see right away it does not cross the x-intercept. So if we were going to graph this, this is going to be a little bit tough. I think this is kind of just like a sort of line looking thing. We got 0, 0. Actually, I think it's more of a parabola looking thing. I'm assuming it's upward facing because this is all positive, so let's try this. And then what we're going to do is we are going to look it up on Desmos just to make sure. So we've got x to the 4th and x squared plus 1. So let's see. X to the 4th plus divided by x squared plus 1. And so you can see that it is kind of a parabola looking thing. How did I know it was a parabola looking thing? It's going to hit 0, 0, and it's not going to pass through it because it has an even multiplicity and it does not have any asymptotes. So parabolas typically don't have asymptotes, and so that's kind of how that was the giveaway for me. So I hope this helps, guys. I should do the last one. Yeah, I'll just do the last one right now. Okay. I was going to make another video, but that's 12 or 13 videos. So let's do the last one. We got x squared minus 4x minus 5 over x minus 3. Let's factor the top. I think this is -5, -4. So this is -5, +1. X plus 1, x minus 5. Okay. Nothing cancels, so there are no holes in this graph. We have division going on. We need to get the slant asymptote. So we've got vertical asymptote. That's at x is equal to 3. Horizontal asymptote. Well, there's none because degree of the numerator is 2, degree of the denominator is 1. Slant asymptote. We got to do long division. X squared minus 4x minus 5 divided by x minus 3. X goes into x squared x times. X squared minus 3x. Change the signs. This is -x minus 5 minus 1. And then I guess it really doesn't matter at this point as long as that's good because the next part's going to be a remainder. So we know it's at y equals x minus 1. Okay, so we'll just stop there. We want zeros, so we have a 0 where the numerator is equal to 1, so that's at x equals -1. Or I'm sorry, where the numerator is equal to 0, so x equals -1, x equals 5. So let's plot these points and see what we can come up with. We've got x minus 1, so that's right here. Up 1 over 1 would be right here. We draw a asymptote. X equals -1. That's like right here. X equals 5. That's like right there. I know this is going to approach this, so it's got to go something like that. And then this has to approach this, so it has to go something like this. And we will check this with Desmos. X squared minus 4x minus 5. So x squared x minus 5. So you see the parabola. Actually, I need parentheses around all that. Divided by x minus 3. And so there you have it. You can kind of see this. We should have also done the zeros for when x is 0. Just to see what that value is. If we plug x is 0 in, we can see that it crosses right here at 1.667. But you don't necessarily have to. I'm just kind of giving you the quickest way to get this down. So I hope this helps, guys. Make sure you practice. Obviously, some of the stuff that I do at the end is kind of just from doing it so many times. The more you practice it and if you hear things that I say and once you start practicing it, you'll start to realize what I'm telling you holds true like all the time. I can't think of examples where it doesn't. So give it a try, guys. I hope you're doing well. If you need help, obviously email me if you want. Come see me on Monday on Tuesday at 9 or 10. We meet at 11:30, I think, or 10:30 or something like that. No, we meet at 11:45. Come see me and then we will be good to go. Oh, well, this is obviously only for fall semester, so if it's a different time for your other class, then negate what I just said. Thank you, guys.